All right, guys, welcome to lesson 13, where we're going to take a little bit of a breather from programming and we're going to look at ASCII. So ASCII is the American Standard Code for Information Exchange, where basically everything is assigned a numerical value. It's based on the American alphabet, so it's easy enough to remember. So if you look in your book on page 63, you'll find this little chart. So the things that you really need to memorize for this is that the numerical value for 0 is 48, the numerical value for capital A is 65, and the numerical value for lowercase a is 97. So if you can remember those three, you will be able to figure out the rest. So like if I asked you what was at ASCII number 56, and if you knew that 0 was 48, you'd be able to figure out that that was number 8. So if you want a more detailed view of this, you'll find it in Appendix D in your book, which starts at page 450. So this is all of the ASCII codes, what it is in hexadecimal, octal, binary, and then, any sort of comment for it. Or like your ampersand, your percent sign, they all have numerical values of what they actually are. So what you'll look at is what the character is and what it is in decimal, because that's what we're using. So this column right here on the left side, and then this character column. So this is much more than you probably even need to know. If you can remember this, you'll be much better off. So ASCII isn't really hard. It's just something that you're going to have to be aware of. Since this is a pretty short lesson, I'm going to go ahead and combine it with a little bit more about character. So we have int, we have double, and we have char. So go ahead and we're going to go into Eclipse and we're going to set up a project in here just to kind of get a little bit more familiar with character. Because we kind of looked at that char at thing a little bit. I want you guys to kind of understand more about it. So one of the things that we'll do in here is we're going to set up and say string, string. You can do that. You can name it a string because that's not string. And so you could not do like char a equals a string, because remember earlier how you can't save a double as an int? It's the same thing with character and string. So we could also set a string to be something. So we could call it lunch. Now we can't save that. It's the same thing. We could save it as the letter A, but it also has an error over here. So let's look. It be resolved to a variable because characters have to be with single quotes. Okay, so string is set up with quotes around the words it contains, whereas char is set up with a single apostrophe around the letter, so on both sides. So it doesn't have quotes, it has apostrophes, and it can only be a letter. So characters are characters, strings are strings. You can't save them as each other, but you can convert them. Okay, so I just made a note of that in my notes. All right, so now I'm going to do something to kind of blow your mind. So I'm going to delete that code that I just put in there. We're going to say int x equals 1. And we're going to say char a equals a. We're going to do capital A. Now we're going to say int y equals x plus a. All right, notice how we don't have an error. All it's saying is that y is not used anywhere. Because what's happening here is with character, it automatically assumes that this is a numerical value. So remember, x is 1 and capital A is 65. So what it's going to print if we do system out print line, if we print y, it's going to print 66. Right? Isn't that kind of crazy? All right, so let's go down a couple lines and let's do z equals a. It doesn't have an error. It is saving the number 65 as z. So because we can use ASCII, we can convert back and forth between characters and integers. So if we print z, it should print 65. Let's run it, and it does. So now what if we can go backwards? We just converted a number or a character to a number. Could we convert a number to a character? So here's a little weird thing about Java. integers can go up to 2 million, but characters can only go up to 65,000. So there are some differences between the two. Since there are so many more integers than characters, it's not a problem going from a character to an integer. But if you want to go from an integer to a character, you can, but you just have to take a couple extra steps. So if we want to convert a number into a character, we have to do a little something that's called casting. So we do char, you can name it whatever you want. I'm going to name it ch equals, and then we're going to cast, and we're going to cast y because it's up here and it's 1 plus 65. So if you look at your chart, 65 plus 1 is 66, so we should get a capital B. So let's go ahead and we'll print ch. I'm just going to copy and paste. Then hit run. It gives us a B. So you can convert from an integer to a character. You just have to cast. Now remember, casting, the type has to be the same on both the left side and the right side of the equation. So char is automatically converted to its ASCII int equivalent. But if you want to get a character from a number, you must cast it to be a character. So it'll be like char ch equals char and then whatever ASCII number you have. Okay, so remember how earlier we said you can't store a character as a string and you can't store a string as a character. Well, remember we learned about char at, so we're going to talk a little bit more about that because I know you guys have kind of used it here and there, but we're going to delve a little bit deeper into it today. So if you have like string s equals w, so remember quotes around that, and you want char c to be w. So what you would do is you'd look at this string, so we do s dot, and then we use char at, and then we're going to put an argument in there. So remember that first index here is 0. So we're going to look at that index 0. Okay, then you would just print C. Just to test to make sure that it works. And it does. I mean, obviously it's printing W, so you can't really tell if it's a char or string, but we know that it is a char because that's what we're printing. We're printing C, which is set up to be a character. Okay, so what if we want to go the other way and we want to convert a character to a string? So we're going to set up like char, we're going to call it D equals, and then I'm going to do capital X. And remember, single apostrophes, not quotes for character. And we say string, and we'll call it P equals. The way you'll do this, you'll put double quotes, then plus P. So it's very subtle. It doesn't really look like you're doing a whole lot, but you're basically adding quotes to the X to turn it into a string. And then you'll do system out print P to make sure that it works. And it does. If you look at page 64 in your book, there's several methods that you can use when dealing with a character. So you can test it to see if it is a digit. You can test to see if it is a letter. If it's a letter or digit, these are all legitimate methods that you guys can use while you're using character. So one of the ones I want to point out to you is white space. So white space can be like a new line, it can be a tab, it can be a space, it can be anything. You can also convert your characters to uppercase and to lowercase. So just the one character, so you convert that variable and then it'll print in lowercase or uppercase. So just like we did with string, but you can do it with character too. For lesson 13, you do not have any programs to write, but you do have some questions. So let me know if you run into any problems. Good luck.